So today we're going to be reviewing all of Chapter 1. If you think back to the very start of the semester, we actually split Chapter 1 into 2 tests. It was a pretty lengthy chapter, so these will be kind of the lengthier notes of our exam review. So the 3 building blocks of geometry are a point, right, just a dot, a line, arrows on both ends, and a plane. So we cannot break anything down more simple than that. That's why we call them the building blocks. Everything else that we look at uses points, lines, and planes to make them. So if things are called collinear, that means that they lie on the same line. Look for that word inside collinear. If it's coplanar, right, we can almost see the word plane on the inside there, means that they lie on the same plane. Oops, so when we get to a plane, remember, think of it kind of like a sheet of paper. It's flat, it's two-dimensional, it has a length here and a width, but there's no thickness to it. But everything takes place on a flat plane. Okay, so you want to name the following and state the number of endpoints and points. So this is just a segment. You could say segment AB, or you could say segment BA. Either way would work. Okay, the number of endpoints, it has 2. And the points that are on this line is really infinitely many. There's infinitely many points in between them. Remember, for a line, we just need 2 letters to name it. So for this one in the middle, you could say line AB. Now it has arrows above it. You could say line AC. You could flip-flop those orders. You could say line BC. There's a whole bunch of different ways to name that line. For the endpoint, since it goes on and on forever in both directions, it has 0. But for the point still, it has infinitely many. Infinitely many points are in between those points. For the ray here, since it starts at point A, there are only 2 names that we could call this. It starts at A, goes through point B. Starts at A, goes through point C. You cannot call this BC or BA. Those won't work. Can't flip around the order there at all. Okay, so if you look at the number of endpoints it has, that'd just be 1. Starts at point A. But the number of points that are on this ray would be infinitely many. Okay, so now we want to find the midpoint of a segment if it had endpoints x1, y1, and x2, y2. We're going to use this formula. So you're going to take the average of your x's, add up those 2 x values, divide them by 2. Same thing with the y's. It's like finding the average because that'd be right in the middle of those 2 values. Right, here's an angle bisector definition. So a ray is the angle bisector if it contains the vertex and divides the angle into 2 congruent angles. So if you want to draw a picture, here's my angle. Here's my angle bisector because it's splitting this angle into 2 congruent angles. Okay, here are some definitions for different types of angles we talked about. If it was acute, we said it was less than 90 degrees. It's small, it's little, it's acute angle. So there's an example there. If it's right, it is exactly 90 degrees. We can never assume that. In order to know it's a right angle, you have to see that box in the corner. Obtuse means more than 90, but it can never be 180 degrees, otherwise that'd be a straight line. If it's a linear pair, these are 2 angles that form a line. Pair means 2, linear means line. Here's my line, here are the two angles. I could say angle 1 and angle 2 are a linear pair. Okay, we really struggle with that one for some reason. Same with vertical angles. This is one of the tougher definitions for us. These are two congruent angles that are formed by lines. So if these are my lines, 1 and 2 would be congruent, 3 and 4 would be congruent. So those are my vertical angles. Okay, complementary just means that they have a sum of 90 degrees. You can complement somebody who's 90 years old. You can't complement someone who's 180 degrees, or sorry, 180 because they're dead. That's how I like to keep complementary and supplementary. That's how I like to keep those definitions straight. Okay, parallel means that you have lines that never cross. Can I scroll down some? No, maybe, yes, no. Weird. Huh. So if things are parallel, they never cross. So if these are my lines, remember the markings. You have the same number of arrows on each. A lot of times you guys like to try showing that they're congruent and just putting little tick marks on them. If it's perpendicular, that means that they cross at 90 degrees. So you would have to see something crossing, and you would have to have it cross at a right angle to know that it's perpendicular. You cannot assume anything. So a polygon is a closed figure in a plane. It's only two-dimensional. It's formed by connecting line segments, endpoints to endpoints. So these are all examples of polygons. Here, these are not polygons when they have rounded edges, when they're not connecting anything together, when they overlap. So here they overlap, so that's why it's not a polygon. Okay, oops. There should be the word consecutive on there. That word means in a row. So if I said consecutive vertices, they're right next to each other. Consecutive sides, they're right next to each other. So then we have something called a diagonal of a polygon. That's a line segment that connects two non-consecutive vertices. So these vertices are consecutive because they're right next to each other. If I look at these two vertices, they are not in a row. So there's my diagonal. So a polygon is convex if no diagonal is outside the polygon. So if I drew this shape here, all my diagonals are inside. This would be like convex. We can say a polygon's concave if at least one diagonal is outside the polygon. So here's a concave polygon. Here are my sides. They go in like a cave, which means that this diagonal is on the outside. Here, all of these diagonals are on the inside. Okay, here's an important table. 3 sides is a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, 8's an octagon, 9 is a nonagon, 10's a decagon, 11's what we called an undecagon, 12's a dodecagon, and when you get to anything 12 or bigger, we just use the value n and say it's an n-gon. So if it had 25 sides, I would just say it's a 25-gon. Nothing fancy there. Alright, so a right triangle, oops. We're missing a slide here. Okay, so two polygons are congruent if and only if they have the same size and shape. We're missing that definition for some reason. So then your next one was equilateral polygon. Is the next blank, all the sides have equal length. In an equal angular polygon, all the angles are congruent. That was another blank. A regular polygon then is both equilateral and equiangular. Sorry, we're missing that side. Hopefully you can follow along and fill in the blanks there. Okay, so if you think about a right triangle, it can only have one right angle. If you think about an acute triangle, it has three acute angles. All three angles are less than 90. If it's an obtuse triangle, it has exactly one obtuse angle. So here's my angle that's bigger than 90. Okay, if it's scalene, it has no congruent sides. So you could draw a triangle, kind of looks like it's leaning over. All three of those sides are different lengths. If it was an isosceles triangle, it has either 2 or 3 congruent sides. Remember, you have to mark them congruent. Those congruent sides are called your legs. And an equilateral triangle has 3 congruent sides. All of your measures for your angles would be 60 since all of those sides are the same.